Recently, we've been studying quadratic functions, and when we looked at a quadratic function written in factored form, it was very easy to identify those zeros, x-intercepts, or those roots. What if it's not written in factored form? So, quadratic formula is honestly the best way to solve for our x-intercepts of any quadratic function. So, our quadratic formula here, negative b plus or minus the square root of b squared minus 4ac all over 2a. It is a mouthful. It is not on our reference sheet, so you need to memorize it. I'm going to give you a couple different ways to memorize it. Most notably is my favorite quadratic formula song, and I'll be sure to link that and share that with you in class. In order to use the quadratic formula, we do need to make sure that our quadratic is first written in standard form, y equals ax squared plus bx plus c. That'll help us identify the specific a, b, and c values that plug into this quadratic formula. So here's some steps. If it's not already written in standard form, make sure that you do that and set our equation equal to 0. Then we'll identify those a, b, and c values. If there isn't a number or a term there, we'll use 0, and we'll plug those values into the formula and solve. We just reviewed how to simplify radicals, so we are not leaving our answers in decimal form. Instead, we are leaving them in simplified radical form. Let's look at number 1. 3x squared plus 180 equals negative 48x. It's not in standard form yet. Remember, we want it to look like ax squared plus bx plus c. So I'm going to add this 48x to the other side. Rewriting it in that standard form, 3x squared plus the 48x plus 180 equals 0. Now I can identify my a, b, and c values here. A is 3, b is 48, and c is 180. Using that quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Two things I want to point out really quickly before we move on is notice that there's a lot of stuff under that square root. There's b squared minus 4ac. That is all under the radical. So make sure as you're maybe simplifying it that you are including all of that in your radical, and all of that is divided by 2a, not just the radical part. So careful there. I definitely recommend simplify as much as you can by hand. So plugging in, we have negative 48 plus or minus the square root of 48 squared minus 4. Now here, the minus 4 is being multiplied with a and with c. Those three things are being multiplied together. So we have minus 4 times 3 and times 180. And again, all of that is under the radical and all divided by 2 times a, or 2 times 3. Continuing to simplify, I'm going to have negative 48 plus or minus the square root of, let's grab the calculator. 48 squared is 2304. And we're going to do minus 4 times 3 times 180 in the calculator. Minus 4 times 3 times 180 is negative 2160. All under the radical divided by 2 times 3 is 6. Let's simplify a little bit more. We got 48, negative 48 plus or minus the square root of, what is 2304 minus 2160? We get 144, and I'm actually really loving that number. Divided by 6. Why do I love the square root of 144? Because it's 12. Happy old 12. Negative 48 plus or minus 12 divided by 6. I'm seeing the home stretch. So you notice in the formula there's plus and minus. That is helping us generate those two separate answers. So I'm going to separate it here and show you. We've got negative 48 plus 12 divided by 6, and we have negative 48 minus 12 divided by 6. So those would give me my two x-intercepts, my two zeros or roots for this quadratic function. Negative 48 plus 12 divided by 6 is negative 6. Negative 48 minus 12 divided by 6, negative 10. So my two answers for number 1, -6 and -10. If I was to graph that standard form equation, it would cross the x-axis at -6 and -10. Okay, 2 solutions are typically expected with our quadratics. Sometimes there is one. There could technically be none, but most of the time we're going to see 2 solutions with our quadratics. Let's try number 2. Again, number 2 is not set equal to 0 yet, so I'm going to add 12x to both sides. So I can write it in that standard form, 4x squared plus 12x plus 5 equals 0. Now I can identify my a, b, and c values. We've got 4 is going to be our a, 12 is b, and c is 5. Plugging into the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, it sounds like a mouthful, but the more you use it, it actually becomes a more simple formula. Plugging in, we have negative 12 plus or minus the square root of 12 squared minus 4 times 5. Those were our a and c values, all divided by 2a, or 2 times 4. Simplifying by hand, negative 12 plus or minus that 12 squared, I know is 144. And I can see that 20 times negative 4 is going to be negative 80. And then over 2 times 4 is 8. Negative 12 plus or minus 144 minus 80 is going to give us 64 divided by 8. And I'm loving that because 64 is a perfect square. Square root of 64 is 8. So we have negative 12 plus or minus 8 over 8. Using that plus and minus sign, we're going to have 2 different answers here. We have negative 12 plus 8 divided by 8 and negative 12 minus 8 divided by 8. Negative 12 plus 8 would be 4 divided by 8. I can simplify as a fraction 1/2. In our other problem, we have negative 20 over 8, which can be simplified to negative 5 over 2. So in this second example, you can see we are still getting those 2 solutions. However, our solutions can be fractions. So not every parabola is going to cross the x-axis right at a beautiful x-intercept, a beautiful x value. It could be crossing at kind of an awkward place like a fraction or a decimal value. Okay, so number 1, 2 solutions. They were both whole numbers, beautiful. Second one, we did have fractions, 1/2 and negative 5 over 2. Number 3 also is not written in standard form yet, so that's positive 2x. I'm going to subtract 2x from both sides, rewriting it as x squared minus 2x minus 4 equals 0. That identifies my a value as 1, right? B is negative 2, and c is negative 4. So as we plug into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's plug in. Now, careful here, our b value is negative. The formula also says negative b. So I have a negative 2 plus or minus the square root of, careful here as well, negative 2 is going to be squared. No matter what happens there in that radical, that b value, when it gets squared, it is always, 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 always going to be positive right there, okay? Minus 4 times a times c, all over 2a, 2 times 1. Simplifying a little bit by hand, let's see. Those 2 negatives are going to make a positive 2 plus or minus the square root of. Here's where I was talking about. So no matter what, this piece should always come out as a positive. Negative 2 squared is 4. That's negative 2 times negative 2. Always going to be positive right there. Minus 4 times a times c. Those 2 negatives are going to make a positive, and 4 times 4 is 16. Over 2 times 1 is 2. Simplifying under our radical, the 4 plus the 16 is 20, divided by 2. This looks good. Am I done? Can I simplify that radical? Yes. Inside of 20, we have a 4 and a 5. So I'm going to show it's broken up there. The square root of 4 is 2. So 2 radical 5. And this looks good as well. There's one more step we need to do. If you can, you must simplify these 3 places. If all 3 of them have a common factor, and they do, we can divide them all by 2, then you simplify that, okay? So our final answer is going to be 1, because 2 divided by 2 is 1, plus or minus, I don't really need to write the 1 there, it's the radical square root of 5 over 1. I don't really need that 1, do I? 1 plus or minus the square root of 5. Final answer. Okay. There are 2 answers represented there. On Delta Math, you can write them separately. You could write 1 plus the square root of 5 and 1 minus the square root of 5, or Delta Math has that plus or minus symbol that you can utilize and write it as 1. But those are our 2 places. They're not pretty. They are going to be very decimally and ugly, but that's just where our parabola is crossing. Again, not at a beautiful x value, and that's okay and normal. Let's do one last one. Number 4, 4x squared minus 36x minus equals negative 69. I'm going to add that 69 to the other side to give us a new rewritten quadratic. 4x squared minus 36x plus the 69 equals 0. That means my a value is 4, my b is negative 36, and c is 69. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Here we go. The formula is negative. We also have a negative 36. Careful there. Plus or minus the square root of. Negative 36 is going to get squared, and when I simplify it in a minute, it's going to be positive, right? Minus 4 times 4 times 69. All of that is under the radical, and all of that is divided by 2a, which is 2 times 4. All right, simplifying by hand, the 2 negatives make a positive 36, plus or minus the square root of negative 36 squared. Again, in your calculator, if you're typing this in as negative 36 squared, your calculator's only as smart as you type into it, you're going to see negative 1296, and that's wrong. We want negative 36 to be squared. What you're telling it in the first one is negative, like a negative 1 coefficient, a negative, and square the 36. Your calculator sees negative and the 36 in the parentheses being squared. Okay? That's wrong. We don't want that. We want negative 36 times negative 36. So use your parentheses, be smart, or remember, we're always going to have a positive number here. This is 1296. Let's also do negative 4 times 69. Gives us negative 1104. Divided by 2 times 4 is 8. Under our radical, we have 1296 minus that 1104 is 192. So we got 36 plus or minus the square root of 192 divided by 8. Can I break down 192? Does it have any perfect square factors? Let's think. Divided by 4. 48. So it divided evenly and beautifully. However, I know inside 48 is another 4, so that I can do better. 192 divided by 16. Divided evenly again, but divided, and the result is 12. 12 has a 4 as a factor as well. Let's do better. 192 divided by 8 times 8 is 64. 64 and 3. Square root of 64 is an 8, so I have 36 plus or minus 8 radical 3 over 8. Can I simplify those 3 places? The 36, the 8, and the 8. Are they all divisible by 4? Are they all divisible by 8? No, just 4. 36 divided by 4 is 9, plus or minus 8 divided by 4 is 2, radical 3, and then 8 divided by 4 is 2. We simplified those 3 places. Again, you could write these separately in Delta Math as 9 plus 2 radical 3 divided by 2 and 9 minus 2 radical 3 divided by 2, or you can use that plus or minus symbol in Delta Math. Okay, but look at all the different answers that we had. We started with number 1, simply nice, pretty, happy whole numbers. They crossed through the x-axis on our graph beautifully. Number 2, there were fractions. It's life. It happens. And in number 3 and 4, that's where we're pulling in our knowledge of simplifying those radicals. Check and look for those pesky little 4 factors hiding out. Simplify the 3 places if you can, you must. And then we saw the same in number 4. Okay, so some good examples there. I love, love, love the quadratic formula. It is a mouthful of a formula, but it'll solve any quadratic function for you. It's not on our reference sheet, so you must memorize it, love and breathe and use it. It'll be your best friend when it comes to our testing on our benchmarks or on your EOC. Guys, I hope you have a great day, and I'll see you in class.